Hello guys, welcome back to ADOBE. Today we're going to see a really cool effect totally done in After Effects, and let me go ahead and play it for you. Alright, this is totally done in After Effects without using any third-party plugins. I didn't use any Trapcode Farm or Trapcode Sound Keys. Everything is done using the default plugins that come with After Effects. Okay, first of all, let me show you how to create the particle reactor using the preset. Later on, I'll show you how exactly to create the preset. So let me go and create a new comp, and let me just drag the audio file and create a new solid. In fact, generate audio spectrum. I'll just drag these points so they're kind of in the bottom of the comp, and make sure they lay horizontal. It's perfect. And make sure, you can pretty much put any color, but let me put it into red. And select the audio layer. Okay, for those of you who don't know, audio spectrum is a spectrum analyzer which comes by default in After Effects, and it's pretty cool. It has a lot of ranges. You can pretty much mess around with the frequencies and the number of frequency bands and the height of each range and all. So let me decrease the start frequency to 1 so we can get a lot of frequencies from 1 to 2000. And let me make sure the hue interpolation to 1 so that I get a color spectrum, and I only want to see to the upper part of the spectrum, and increase the thickness, say 5.5 is fine. And as you can see, the spectrum isn't that high here, so let me just increase the maximum height to 4000, and it pretty much works fine. And let me decrease the audio duration to 50 so that they're more spontaneous. You just have to mess around with the settings. It depends on the audio file. It's not a big deal, you'll get used to it. And decrease the softness so we can get cool values. And as you can see here, let me just increase the frequency bands to 80 or say 85 so we can get more accurate data. Okay, so let me just run preview it. As you can see, all the drum beats and all the drum beat sounds, you can see this part of the spectrum is reacting to that frequency, and those water sounds, those splash sounds and all. Actually, this part, this part here from this yellow to blue, this part of the spectrum is reacting to that sound, and you can see in the background the different frequencies reacting to different sounds. So it kind of works like Trapcode Sound Keys, but you don't need Trapcode Sound Keys in this method. It's just create a new null object. If you ever use Trapcode Sound Keys, you pretty much know what I'm doing here. But this acts like a range to extract the keyframe data, and just apply the preset, and boom. And make sure you specify the spectrum layer but not the audio layer. Make sure let's call it spectrum, and make sure you actually specify the spectrum layer but not the audio layer. Okay. Now, as you can see, this is the final range value, and this is the keyframe data. And thinner the value is, the thinner the range is, the more range value you get. This is just like trap code sound keys where you extract beats. In the same way, if you move this thing away, you don't get any keyframe data. If it's here, it's pretty much converting beats into keyframe values. And the good thing about this method is, about this preset is, unlike trapcode sound keys, you need not insert keyframes here. And that's a good thing, because sometimes when I'm using sound keys in some pretty huge projects, if I need to change the audio a bit, or if I need to move the audio a bit, again I need to reinsert all the keyframes, and sometimes I forget to do that, and it all just screws up. So, and another big advantage is you can just have multiple ranges. You can have as many number of ranges you want, and you get really cool, final range values. You can just, pick whip this, value to any, property you want in After Effects. Look, now with 0, as soon as that beats, the beats come in the sound, you see, you get the keyframe data here. It's pretty much like ranges in sound keys. You know what I'm talking. So let me just animate. Let's create the sound reactive particle layer. So let me put it back to 100%. And as we saw in the previous RAM preview, the beats, the drum beats are reacted to this part of spectrum, whereas the water effects are reacted to this part. So let me delete one of this. We don't need 3, and drag one of it, and kind of create a range. So whenever spectrum goes into that range, you get a keyframe data here. Okay, that's perfect. And let's go back here and bring this down a bit. So you can get, kind of like all the high values. That's perfect. So, as you can see, that's pretty much, you can get, you can pick whip this thing to, any property you want. Okay, now just for the sake of, speed and, to get the range, I'm converting this expression to keyframes. Okay, now let's see the range of it. So as you can see here, the values are from 0 to 40, just keep that in mind. And in the same way, let's go to the second range, and let's rename this as range 1, rename this as range 2. Now let's go to this range, and let's see, and let's convert this to keyframes. Okay, now as you can see here too, in the same way, the range is from 0 to 40, so let me just keep that in mind. So now let's create the particle reactor. So let me create a new solid, and wave world, and go to height map, and here basically it produces waves. So it is used to simulate various things in After Effects. So as you can see, the amplitude is the amplitude of the wave. You can this thing has a value. You can pretty much have a value from 0 to 5, so it can go beyond 5. So let's option click this and uh, you know animate it to slider. As you can see, we the maximum value, the range of this amplitude is from 0 to 5. So we need to convert, and the range of this particular property is from 0 to 40 something, So we need to convert this to from this range to the range of the amplitude. So let's call this x. And linear, it changes the range linearly of x. That's this property from 0 to say 50 to 0 to 5. Now you get more, or your reactive map here. And option click the frequency. Frequency is the frequency of the waves, number of waves per second, and just go to range 2 and pick whip this thing to the final range value here. So this is the most important step. Well, we got our wave map, and that's like the most important step in this effect. So now let me apply an effect called CC ball action. Now CC ball action is a bit like trapcode form, but I don't say it's as advanced as form, but it is pretty cool. It can do some really good stuff with it. So let me it has some really cool twisting properties. You can twist the layer, the balls, the layer which has all the balls, and you can pretty much control the grid spacing. The bigger the grid is, the more magnification you get into the grid, and the smaller the grid is, pretty much 2 is fine. And the ball size, you can decrease the ball size to like say 35. And this is the most important step. You need to change the twist property from X to brightness. So what it does is it basically twists based on the luminance, the brightness values of the source layer. That's nothing but our black solid here, and the wave map we created using the plugin Wave World. So as you can see, we already got a really cool audio reactive particle effects going on. And you pretty much want to rotate it, make it more, say like 200 something. And you might be interested a bit in scatter, like say 1, so it just looks a bit more organic, and rotate on the x-axis a little bit. And now you want to animate it with the camera, so let's go create a new camera. Okay, and go to transform and option click the position and wiggle it around 0.3 and 400 pixels, so 0.3 times per second and 400 pixels. So what you see is you really get a really cool, you know, let me just zoom to 50% so you can see more clearly. Get a really smooth camera movement, random camera movement, and it looks really cool. And you just don't want to see these null objects, and so let me deselect the null objects. Okay, so all you have to do is create a new adjustment layer and get the color settings right. So first let tritone, and if this looks great, I think it looks great, but let me just put something like purple, and then I'll add glow. As you can see, we pretty much got a really cool, looking thing already, but let's change it to alpha channels. So the glow is based on alpha channels. And as you can see, the highlights, they look more pale here, like more white. So let me just change to a really, subtle purple, or any color you want, but really, bright. Okay. And you get a really cool particle reactor going on. So let me RAM preview it, and as you can see, the colors still look a little bit weird, so let me decrease the glow threshold so we get more glow into it, and change the color B to really dark thing here, and let's increase the glow intensity, and let's go back to our solid here and change decrease scatter to 0 so it looks more like a foam. Okay, now let's go back to the adjustment layer and decrease the midtones. To a less bright thing. Okay, now let's RAM preview it. Okay, now let's watch it. Okay, in the next segment, let's see how I created the preset. Before we actually start doing audio analysis, let's look at a cool, expression called sample image. Sample image works, basically like this. It actually extracts the color data from, a certain area of an image or a composition or anything. Basically, it extracts, the color sampling. It samples color from a certain area, based on its horizontal radius and the vertical radius. So here I create this little shape. So let's say if we apply sample image expression to this point, and say the horizontal radius is say this this length, and the vertical radius is this length. So this expression basically samples the color data throughout this whole area, through all this yellow, through all this region, and it gives the output in the form of RGBA, red, green, blue, and alpha. So let's do a sample, of that. So let me, do select everything here, and okay, here have, okay, let me just put it to 50%. Okay, here I have an image, and I need to extract, say, color data from, like, from various points. So let me go ahead and create an effect and color control. So it's just like slider control, but it's for color. Effect, expression controls, point control, and let's call this point color or color point, whatever. And now I'll click color control. Let's have a point called P. So let's pick with this to this point, and now let's apply the expression sample image P. Say the horizontal radius is, say, 10 pixels, and the vertical radius is, say, 10 pixels, and okay, I did not close a bracket there, so okay, I do such mistakes always. So as you can see, where you put the point here, it actually samples the data out of the whole rectangle that is actually 10 and 10, 20 by 20. The horizontal radius is 10, so the whole total length of the rectangle is 10, and the total height of the rectangle is 10. So sorry, 20, and the total height of the rectangle is 20, so it's 20 by 20. So it samples color data and produces an average value, and it gives RGBA. Suppose let me create a new slider value. And let me all click it. Suppose we just need the, let's copy this, and suppose we just need the red values, the R values. We don't need the whole color itself. So let's call this S, and let's put S square bracket 0. So what it does is it just gives the red value in the in the sample area. So you pretty much get the red value. Look here, you don't have much red value, it's 0. It's pretty much like that. And you can get the blue value. I mean the green value is 1. So here it's a green value because it's RGBA. And for the blue value it's 2, 0, 1, 2, 0, 0 for R, 1. It's basically an array. So, and it also gives you the alpha value. So let's put 3 in it, and let's see. So as you can see, everything here shows 1. I mean, there is something here, and it's not transparent. So it's totally, as long everything here is is opaque, and there is an image here, so the alpha is always 1. Now let me just move this image a little bit, and let me just bring this point here. As you can see, Here there's nothing, the alpha is 0, and here the alpha is 1, and it takes an average of the rectangle it forms around the point, and it gives you an average alpha value. So that's the key, that's the key for RF, audio analysis today. So just keep that in mind. It basically extracts the color data, including the alpha value. Also, let me show you the difference between layer space and comp space. As you can see, we have a blue, solid here, which has anchor point here, and the value of anchor point never changes with respect to the layer space. But with respect to the comp space, which is the white grid, it changes because with respect to the composition, the point is moving, but with respect to this layer grid, the point is not moving. It's just static. So that's the difference between the value. I mean the position value with respect to the layer space and the comp space. This is really important because once you scale this object down or something, say we have a point up here with respect to the layer space, on the upper left corner, and when you scale it down or when you scale it up, it's the value of its position with respect to the layer space never changes, but the value of the position of this point with respect to the comp space changes. Just keep that in mind, and and let's start our audio analysis with these two things in mind. Okay, now the audio analysis. So let me create. This is kind of like for the advanced users. So if you don't understand, just don't worry. It's just a preset. But just drag the audio layer, and the same way create a new solid, and effect, generate, and audio spectrum. In the same way, as we did before, arrange it here. Select 426, yeah. Here, make sure it's a straight line, and specify the audio layer, and you can get spectrum here. Change it to red. You can have any color, it doesn't matter. So let's leave it. And if you want a colorful spectrum, digital side A, and increase the frequency bands to 75, and maximum height to and decrease the audio duration to like 15, so you can get more samples, and decrease the start frequency. So as you can see, we get a spectrum here, which is reacted to various frequencies. Like this part of the spectrum is reacted to a particular frequency, and this part is reacted to a different frequency. So like trap code sound keys, we'll have a range here in the null object. So if you have seen the preset before, basically what it does is it actually samples the alpha values of the particular area of the null object. So basically the more number of bars. Let me just increase the maximum height and frequency bands. So basically the more number of bands we have here, the more amount of alpha values we can actually get from this area. Say as I showed you in the image sampling before, there's nothing here, so the alpha value of this region is 0. And say if I keep this here, the alpha value, is greater than 0, but not equal to complete 1, because it actually takes the average of the whole area. And here, if we put here, we can get a higher value because there's more bands here, and there is something here which is not transparent, so we can get a higher alpha value within this range. So basically we just extract the alpha value of the specified area of the null object, and that's nothing but the keyframe data. So how we do that, so let me just rename this null object range, and this thing as spectrum, and let's go to the range layer, and let's first of all we need to find the area of this null object. Basically while setting a range, we can just scale it down, or scale it up, down. Then it's kind of hard to get the area with respect to the size of the null object. So let's like do it in a different way. So let me create a new point control. It's basically blank point. We can move on just a bit, and please note that it's in layer space. So let me alt click it and put it to 0, 0. So no matter what happens, this point always stays at this this point, the first point of the null object. And let's duplicate this and change this to 100, 100. That's the size of the null object by default is 100 pixels by 100 pixels. So no matter what happens, even if you scale it down or scale it up, what happens, this point always stays at the end of the rectangle here. So we have 2 points here, so basically we can get the length and the breadth of the rectangle, and we can get the area, and we can sample the alpha value from the anchor point. So by default the anchor point stays at 0, 0 in the null object. So we need to have the null object at the center of the rectangle, but not at the corner. So let me go ahead and change the anchor point to 50, 50. So as you can see now, the anchor point is in the center, so you can just scale it down at any angle or any way you want. Okay, now for the alpha sampling. Go to effect and generate, expression controls and slider control. So let's all click it as usual. Okay, now let me have some space for this effect. Okay, now let's create a new point called, say, P1. Let's call it P1, and let's pick whip this to this point. Now let's create another point called P2, and let's pick whip this to here. So first of all, we need to get the length, the distance from here to here. And as you know, both of this point and this point has the same x value. So the difference between the two x values of this point and this point is nothing but the length of the rectangular null object. So let's call it length, and it's nothing but the x values. So P2 0. By default the P1 has an array of 2 values, x and y. So to get the first value, that's the x, we need to put 0 here. the array starts from 0, so the first value is 0, so that's nothing but the x position of that point, minus p1 0. So sometimes, you know, when you scale it on, we might not always get positive values. So for the length should always be positive to calculate the area. So, you know, just for, you know, time being, just put math dot abs. Okay, that was great. And let's put the breadth. I would just say, you know, height. And the same way, where the height of this thing is nothing but the difference in the y values of these 2 points. So math dot abs and p2 1 minus p2, sorry, p1 1. Okay. Now, as I told you before, all the points here, these are with respect to the layer space, but we need to convert them into the comp space. So just make sure you put 2 comp before, so that, you know, the points automatically change to the comp space, because we need to sample, you know, the layer beneath it, that's the spectrum layer, which is nothing but the comp space. Let's put 2 comp here. Okay. Now let's create a new point called A, and that's nothing but the anchor point. Even the anchor point is with respect to layer space, so let's change it to the comp space. Actually, it's fine. Okay, now it's time to sample, you know, the image. So let's call the sampling data as S, which is equal to sample image from the point A. And now we got the length, so the horizontal radius would be half of the length, and the vertical radius would be half of the height. So let's put length by 2 and height by 2. And let's create an array so it knows the radius. Okay, now sample image returns 3 values, the RGBA, so that's nothing but the S0, that's the red, and the S1, that's the green, and the S2, that's the blue, and the S3, that's the alpha value. So we don't need the RGB. I mean, you can pretty much, you know, go for the RGB too, but, you know, by always prefer sampling the alpha value because it's more standard. And, you know, now as you can see, even though you change the null object here, you don't see anything here, because right now this expression is sampling the color data of the null object, not the, you know, the layer beneath it. So let's, you know, apply new effect, expression controls, layer control. So let's call, you know, let's create a new expression. Let's call it L, and just pick whip this to here. Okay. Now you need to sample, you know, the layer which we choose here, So let's change this expression to L dot sample image. So as you can see now, let's, you know, okay, now if you select this null object, as you can see, it's still we're not getting any value here because we didn't select the spectrum. Make sure you select the spectrum but not the audio layer. Okay, so if you select the spectrum, as you can see, this works pretty good, but you still, don't, everything is in point values here. This is because, basically a sample image actually outputs value from 0 to 1. So let's multiply this by 100. So now you got a really, cool range selector, and you can pretty much decrease it. As you decrease it, you can see you get higher ranges, higher values. Basically, you can increase the thickness so that you don't get this little drop, and decrease the softness. So you can pretty much get the range here. If you move back, it's just 0. So that's how we created the sample image function, and it works pretty good. And I would say sometimes you can get more accurate data than trap code sound keys, or but it's up to you. And you can get more ranges from duplicating the ranges, and as you can see, you can get different values just based on that. And I always prefer having multicolor spectrum, just because we can get what do I say, we can easily identify the various ranges. And also I would want to let you know, make sure you don't select the composite on original, because if you select that, everything is just black, and you get alpha value no matter what, where you put it. It's just 100, it's just 1, because everything here is opaque now. So make sure you don't select it, composite original, and make sure the spectrum layer is comp size. So that's how we do the analysis. Thank you for watching. Have a great day.